All right, here are solutions to perfect problem 2 for Math 111, a fairly challenging, I guess, problem. I give you this equation here, and what I ask you to do is solve it, but do so 3 different ways. Factoring, completing the square, and using the quadratic equation. And because of the numbers I chose, none of those 3 ways are all that easy. But I guess we'll figure it out. So maybe I'll just go in order. Factoring here. First thing to know about factoring is it only is useful to factor if you've set your equation equal to 0. So what I'm saying is before you even get started, subtract 16x from both sides of the equation and subtract 15 from both sides of the equation to get here. And then look at this thing, and there's kind of 2 general strategies for factoring, or at least 2 that we learned in our class. One that's applicable when your leading coefficient, the number in front of your x squared, is a 1, and one that's applicable when it's not. In this case, it's not, which is unfortunate because those become the harder of the 2 types of problems. But that's what we'll deal with here. So my leading coefficient is not a 1. There's lots of different ways you can factor when your leading coefficient is not a 1. A lot of people prefer to just kind of guess and check, to jump from here to the factored form, which is totally fine. If you can do that, that's good. But I don't like teaching it that way because it kind of relies upon this guess and check. It kind of relies on you doing steps that are challenging for some students. So what I'm going to do is show you another way that you could solve this. It's a little bit longer, don't get me wrong. It's a factoring by grouping method, but that's what we're going to try to do here. So it's a 3-step process. Step 1, what you try to do is find 2 numbers that, and you need them to add to b. So add to whatever the coefficient on your linear term is. So in this case, they have to add to negative 16. And then multiply to, and you're like, oh, slow down. Yeah, I got this. They multiply to negative 15, right? No, they don't. They don't multiply to c. They multiply to the product of a and c. So this 15 times this negative 15, they multiply to negative 225, which is going to be kind of rough, but maybe we can figure it out. Again, this 225 came from this 15 times this 15, and I think that that's hard to do. The way I tell students to focus on this is don't worry about what adds to negative 16, because lots of numbers add to negative 16, but focus on what multiplies to negative 225. Maybe I'll make a list of the numbers that multiply to 225 positive, and then I'll figure out the negative later. 225 came from 15 times 15, so one way you can get there is 15 times 15. But I can kind of, this 15 is a 3 and a 5, so I could sort of take a 3 from here and put it over here. In other words, I could make this 5, and then this would have to be 45. Or I could take a 5 from here, and then this would be 3, and this would be whatever 5 times 15 is, in other words, 75. What else could I do? Well, like I took this 5, or I took a 3 from this side and made it 5 times 45. But I could put stuff back over here. I could take a 5 from this side and bring it back over to this side, and that would give me 25 times whatever times 5 is equal to 45. I think that's 9 in this case. And that might be enough. In fact, I think that is enough. If you start glancing at these, none of these will be your answers to step 1. First off, you don't want them to multiply to 225. You want to multiply to negative 225. And maybe I should add 1 times 225 just to make my list complete, but that won't be the right one. To make it to multiply to a negative number, I just got to think one of these guys is negative and one is positive. But it has to add to negative 16. So if I make one of these negative and one positive, it's going to add to 0. If one of these are negative and one's positive, it's going to be a big number, either 40 or negative 40. Ditto here, 72 or negative 72. But here it gets kind of interesting. These numbers are close enough that if one of them is negative, I might be able to get them to add to negative 16. In fact, if the 25 were negative, negative 25, and the 9 were positive, I think what I get are 2 numbers that satisfy these 2 criteria right here. Once you have those 2 numbers, what you want to do is step 2, which is where you replace your b, your negative 16x, with your answers from step 1. So in this case, negative 25x and positive 9x. So what I'm saying is rewrite this guy. So I got 15x squared. But instead of writing the minus 16x, I'm going to write minus 25x. And then and then a plus 9x. And then I got this minus 15 equals 0. So that's step 2. And then step 3, we're doing what's called factoring by grouping. So factoring by grouping is something we also talked about in our class. We talked about it as a method. Let me write this first. Writing and talking is hard, which is bad when you're trying to make videos. Factor by grouping is what I should have written here. We talked about factoring by grouping as a method that's useful when you have 4 terms. Turns out you can do it when you got 6 terms or 8 terms as well, an even amount of terms. Up here we only had 3 terms, 1, 2, 3, but we did this step 1 and step 2 trick to rewrite this so it's 4 terms. So now we kind of make groups out of them. I got this first group here, 15x squared minus 25x. And what I want to do is find their greatest common factor. They both have an x in them, but they also both have a 5 in them. So I can factor out a 5x, and what that will leave me with, if I just pull it out of these first 2 terms, is a 3x minus 5. Note that if you took this 5x and distributed it back in, you'd get these 2 terms up here. You can't pull a 5x out of these guys, but that's okay, they're not in the first group. What you now want to do is view your second group, this 9x minus 15, and factor something out from them so that you are left in the parentheses with the same thing you have the parentheses over here. And that will always work if you did step 1 and step 2 correctly. So I stare at this thing and I'm like, I want to be left with 3x minus 5. How am I going to get there? Well, if I took a 3 out of each of these, a positive 3, what I would have left behind would be a 3x from that term and a minus 5 from that term. And because I have, the way to view this is now it's 2 terms. Here's one of them, this entire thing, and here's the other one, this entire thing. And they both have something in common, namely what's in the parentheses. And that will always be the case, by the way you did these. So if you have something in common, you can factor it out. Just like when I had a 5x in common here, I factored it out from the first 2 terms. Now I have a 3x minus 5 in common. So I can factor that out of these 2 terms. I can take that 3x minus 5 and pull that out. Now it's not here anymore or here, just like the 5x was no longer here or here. I pull it out, and what's left behind would be this 5x and this plus 3. And what I've managed to do is factor this guy. And now that you have it factored, it's relatively easy to solve the problem. Sometimes something equals 0, so that tells me that either 3x minus 5 is equal to 0, or the 5x plus 3 is equal to 0. And now I can solve each of these. In this one, I'd add 5 to both sides of the equation, and then divide by 3, and get x equals 5/3. In this one, I would subtract 3 from both sides of the equation, and divide by 5, and get x equals negative 3/5. And those are my solutions, and this is my factoring method. I'm also asked to solve this by completing the square. Man, that's going to be hard too, but okay. Completing the square. When I'm trying to complete the square, what I want to do is get all the terms with an x in them on one side of the equation and the constant term on the other side. So my starting spot will be 15x squared minus 16x, and that's equal to 15. And the completing the square method we learned in class, you need a 1 as your leading coefficient. And you don't have a 1 as your leading coefficient, you got a 15 as your leading coefficient. So to make that 15 a 1, I'm going to divide both sides of the equation by 15. That'll make that x squared minus 16/15 of x, that's going to be miserable, is equal to 1. And now this is not a perfect square on the left-hand side of the equation, but there is some number I can add here to both sides of the equation that'll make it a perfect square. And the way I figure out that number is it's half of this. Half of 16/15, or really negative 16/15, is negative 8/15. And negative 8/15 squared gives me, maybe in a different color, positive 64 over 225. Again, this number, the top here, this 64 came from 8 squared, and the bottom, this 225, came from 15 squared. If I'm going to add it to one side of the equation, I better add it to the other side of the equation as well. And what I am guaranteed with is a perfect square on the left-hand side of the equation. In fact, it's a perfect square that's of the form x minus half of this number. In other words, x minus 8/15. So I got x minus 8/15 squared is what this entire thing is equal to. And over on this side of the equation, 1 plus 64 over 225, we'll view this as 225 over 225, and then you can add them together. You get this common denominator of 225, and in the numerator, you would have whatever 225 plus 64 is. What's that, 289? Shouldn't ask that like it's a question. State that with confidence, I guess. 289. Okay. Now I can solve this. I only have the letter x written one time, so I can solve this equation. The way I'll solve this equation is I'll first take the square root of both sides. X minus 8/15 is equal to the square root of this side. Well, anytime I take the square root, I got to put in a plus or minus. Square root of 289 over 225. Turns out that's a perfect square. You might need a calculator to figure out what fraction that is a perfect square of. The 225 in the denominator, well, we got that from 15 times 15. So the square root of 225 is 15. The square root of 289, well, 289 is a little bit bigger than 225. So if it's a perfect square, it's probably the perfect square of some number a little bit better than 15. Maybe if you try a couple, try 16, it won't work. Try 17, it will work. The 17 squared equals 289. Feel free to use a calculator to figure that out. So now I'm trying to solve this. I got x equals, if I add 8/15 to both sides of the equation, I get 8/15 plus or minus 17/15. In other words, I get 8 plus 17, which is 25 over 15, or 8 minus 17, which is negative 9 over 15. And if I reduce those two fractions, I can cancel out a 5 in each of these, and I'm left with 5/3. I can cancel out a 3 in each of these, and I'm left with negative 3/5. And sure enough, that matches with the two answers I got over there. Need to separate these a little bit. One more way you can solve these is by using what we refer to as the quadratic equation. The quadratic equation, try that again, tells you that if you have a quadratic equation of the form ax squared plus bx plus c equals 0, then the solutions to that equation are x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So to get this in the proper form to solve it, I want it to be ax squared plus bx plus c. I want it in this form right here. I want 15x squared minus 16x minus 15 equals 0. And that tells me that the value of a is equal to 15, the value of b is equal to negative 16, and the value of c is equal to negative 15. Now I just go plugging stuff in. I got x equals negative 16, in other words positive 16, plus or minus the square root of b squared. 16 squared. To do that in your head or with the calculator or something, maybe I'll just do it off to the side here. 256. Yeah, I think that works out. So I got a 256 here from my negative 16 squared. And from that I want to subtract 4 times a times c. So I want to subtract 4 times 15 times negative 15. I'm subtracting a negative number there. And when you subtract a negative, that's the same as adding. And the value that I'll add will be whatever 4 times 15 times 15 is. Well, I saw above 15 times 15 was 225. And 4 times 225, think about it like you got $2.25. So 4 of those, you'd have $8, and then 4 quarters, you'd have $9. What I'm getting at is this is 900 here. Use a calculator. Divided by 2a. A is 15, so 2a is 30. So I got 16 plus or minus the square root of 256 over 9 plus 900 is 1,156. Wow, these numbers are getting miserable. 1156, turns out that's a perfect square. Well, frankly, I don't know. You can pull out a calculator and figure that out. But I know that one of my answers should be 5/3. And so if one of my answers is going to be 5/3 and I have a 30 in the denominator, then this has to add to 50 when I add whatever number's over here. And in order for that to add to 50, the square root of 1156 must be equal to 34. So I'll kind of cheat there. I already know what the answer is, so it must be true that 34 squared equals 1156. In other words, the square root of 1156 is 34. Use a calculator for that if you want. So now I got 16 plus 34, which is 50, over 30, or 16 minus 34, what's that, negative 18 over 30? And if I reduce 50 over 30, I get 5/3. And if I reduce negative 18 over 30, these both had a 10 in them. These both have a 6 in them. If I take a 6 out of the top and the bottom, I get negative 3 over 5. And so I get the same answers that I had before in each of those two methods. just using a different method, the quadratic equation. I tell you to comment on the advantages and disadvantages for each one. I don't know, man. I'll kind of leave that up to you. I don't need to write those down. Generally speaking, complete the square. That was probably the quickest of these three, which is kind of crazy. The numbers got a little bit hard when this value of b is a fraction. It can make things challenging, or an odd number can make it challenging. We had a lot of square roots to deal with, so that was hard. The quadratic equation, that was nice. I mean, I wrote the least amount of stuff over here, but it was really hard to figure out. I had to do a lot of big numbers pop out of the quadratic equation. The square root of 1156. Without a calculator handy, that can be kind of miserable. But not a lot of steps, so I guess that's nice. Factoring, never had to deal with square roots in here. It's kind of nice. Avoided that step. The downside is that sometimes factoring can be challenging, specifically step 1 here in this factoring by grouping idea. But I don't know. I think I kind of like, in this specific instance, this would be my favorite, second favorite, third favorite. But I'll leave it up to you and let you talk about the advantages and disadvantages, and I'll stop this video here.